Alright guys, we're going to start with Unit 1. Introduction. One of the oldest forms of the communication between people in the use of a drawing. A drawing is a means of providing information about the size, shape, or location of an object. It is a graphic representation that is used to transfer the information from one person to another. Okay, so a drawing can be anything from a sketch all the way to a blueprint. So a sketch is just something to quickly transfer from one person to another, where a drawing is something where you're able to reproduce the part off of whatever you draw down. So you need to have all your dimensions and everything on a blueprint. Where a sketch is just, you could draw a square and say, hey, I want a part that looks something like this. So you have many different kinds of drawings. They're usually specialized language among engineers, designers, and technical fields. These industrial drawings are not known by many names. They are called mechanical drawings, engineering drawings, technical drawings, or working drawings. Whatever the term, their intent remains the same. They provide enough detailed information so the object can be constructed, like I said earlier. Engineers, designers, and drafting technicians commonly produce drawings used among computer-aided design and drafting equipment. So CAD is a computer-aided design. The application of a computer technology has led to greater efficiency in drawing production, duplication. CAD systems have rapidly replaced the use of mechanical tools to produce original drawings. So, computer-aided design and drafting. So CAD systems are capable of automating many repetitive, time-consuming drawing tasks. The present technology enables the drafter to produce or reproduce drawings to any given size or view. These three-dimensional qualities may also be given to the part, thus reducing the confusion about the true size and shape of an object. So, if you were looking at one without all the actual CAD programming, it would take you a long time to put all this detail into a part. Whereas once you put it in a CAD drawing, you can skew it every which way, so top, front, right, everything, and you only have to draw it once versus 4 times or 3 times. CAD systems usually consist of 3 basic components: hardware, software, and operator or users. The hardware includes a processor, a display system, keyboard, plotter, or digitizer, often called a mouse. Software includes the programs required to perform or design of drafting functions. Software packages are available in many forms depending upon the requirements as a user. The CAD processor is actually the computer or brains of the system. And then we know what a keyboard is, and we know the screen is commonly a LCD or CRT digitizer, and the digitizer is the mouse. So the plotter is a printer that produces hard copies of a design or print form. You might want to remember that. Industrial drawings are usually produced on a paper material called vellum or a polyester film known as mylar. Mylar is a clear polyester sheet that is a matte finish on one or both sides. The matting provides a dull, granular drawing surface well suited for pencil or ink lines. Mylar is preferred over vellum in some applications because it resists bending, cracking, and tearing. A completed industrial drawing is known as an original or master drawing. So blueprints, because some original drawings are delicate, they seldom leave the drafting room. They are carefully handled and filed in a master file of originals. When a copy of original is required, a print is made. The term used to process the reproducing an original is known blueprinting. So most of the time, whenever you're actually machining a part or welding a part or whatever, you're not really touching the original, because in older days it was so hard to draw them originally that they didn't want to have to redo it, so they just reproduced them and give you that part. The earliest form of blueprinting produced a white line, blue background. This early process, which was developed in England more than 100 years ago, has since changed. Modern reproductions produce a dark line with white backgrounds, duplicating, simply called a print. However, the term blueprint is still widely used in the industry. So that's why it's called blueprint, because in olden days the paper was actually blue. Industrial drawings and prints are made for the purpose of communication. They are a form of nonverbal communication between a designer and builder of a product. The industrial drawings are referred to as universal language. It is a language that can be interpreted and understood regardless of the country. Also, drawings and prints become a part of contract between parties buying and selling manufactured components. A picture or photograph of an object would show how an object appears. However, it could not show the exact size, shape, and location of the various parts of the object. Industrial drawings describe size and shape and give information needed to construct an object. The information is presented in the form of special lines, views, dimensions, notes, and symbols. The interpretation of these elements are called print reading. There are several methods available for reproducing drawings. So the first one is the chemical process. The ammonia process, often called the diazo process, is a common method of print reproduction. To produce a copy, the original is placed on top of a light-sensitive print paper. Both the original and the print are fed into the diazo machine and exposed to a strong ultraviolet light. As the light passes through the thin original, it burns off all sensitive areas not shadowed by lines. The print paper is then exposed to ammonia atmosphere. The ammonia develops and all sensitized areas left on the printed paper. The result is a dark line reproduction of a light background. The silver process is actually a photographic method of reproduction. This process is often referred to as microfilming or photocopying. This method is rapidly gaining popularity in the industry due to the storage and security reasons. The most common procedure followed is to photograph the original drawing and gain a microfilm negative. The negative is then placed on an aperture card and labeled a print number. Duplicates of the microfilm are produced with the aid of microfilm printer using sensitive photographic materials. Enlarged or reduced prints can be produced using this process. The aperture cards containing microfilm are very small, therefore cataloging and filing take very little room in storage. They are much easier to handle than the delicate originals, which must be kept in large files. Microfilming is often done for security reasons. As many as 200 prints may be placed on one roll of microfilm. They can be placed in a vault or secure area. And then you got the electrostatic process. The electrostatic process has gained in popularity for industrial drawing reproduction. Although once limited the reproduction documents of small drawings, new machines have been developed that allow large drawing duplication. The electrostatic process, commonly known as xerography, uses a zinc-coated paper that is given an electrostatic charge. The zinc coating is sensitive to ultraviolet light. When exposed, areas shadowed by lines and original produce a dark line copy. So, the CAD process. As previously described, the CAD process uses a computer technology to automate many drawing tasks and to file the original drawings electronically. One advantage of the CAD system is the ability to rapidly access stored drawings for reproduction or when a revision is required by simply sending a message from CAD processor to an output device called a printer or plotter. So, this is going to be what you're doing on your first assignment. We're going to keep this week pretty short, and so just go on your canvas and your assignment will be on there. Thank you.